Hello. Hello.
Yes.
Yes, ma'am.
Hello, ma'am.
Hello. I'm audible, sir?
Yes, Lata ma'am, you are audible.
Okay. Thank you. Thank you so much. Okay. Let's start the conference now. Good morning, one and all. Welcome to our online international conference on communication and computing system organized by ICARS New Delhi. And a very warm welcome to our dignitaries, Dr. Kishan Lal, Professor Mandoria, sir, Dr. Ali Ahmadian, Dr. D.K. Lobial, sir, Professor B.M.K. Prasad, Dr. Rishabh Anand, and Dr. Karan, sir. Believe in yourself and all that you are. Know that there is something inside you that is greater than any obstacle. Said by Kristen D. Larson, the purpose of our conference is to provide a platform for interaction between scientists from industry, academia, and other areas of society to discuss the current trends in communication and computing system. So, with a great start, here I would like to welcome our General Chair, Professor B.M.K. Prasad, ICARS, New Delhi, who is a professor. He has done his master's and PhD from Patna University in the year of 1984 and 1990 respectively. He has his credit to have number of research papers published in national and international journals. He has also having the credit of having number of books published by various publishers, and he has been participating in number of seminars, symposiums, workshops and conference for national and international levels, and accordingly visited various places in India and abroad. He has always been active over academic programs throughout his career. Currently, he is associated with Dronacharya College of Engineering, Gurgaon, as a principal director for more than 22 years. So, welcome, sir. Over to you, sir. PMK Prasad, sir.
Yes, good morning.
Good morning, sir.
Just a minute, please. We are waiting for the chief guest. Okay, few minutes more.
Okay, sir.
Good morning, everybody. On behalf of all the members of the organizing committee of International Conference on Communication and Computing Systems, I welcome our honorable chief guest, Professor Dr. Kishan Lal, co-chair, IMP for Science, the Global Network of Science Academics, immediate past president of Indian National Science Academy, New Delhi, and former director of National Physical Laboratory, New Delhi. Professor D.K. Lobial, former dean and professor at ICCCS, JNU, New Delhi. Professor H.L. Mandoria from G.B. Pant University, Pantnagar, UP. Dr. Karan Singh from School of Computer Science System, JNU, New Delhi. Professor Mehmet Hakan Karata of Kuwait University. Dr. Ali Hussaini from Malaysia. The delegates, all the dignitaries, speakers, participants, students of various organizations from all over the world in third International Conference on Communication and Computing Systems, which is jointly organized by JNU New Delhi, GB Pant University Pantnagar, UP, and International Center for Advanced Research and Studies, New Delhi, for 2-day schedule from 5th of Feb to 7th of Feb today in the morning. For the last 3 times, we have been organizing International Conference on Communication and Computing Systems. Since after having the discussion with Professor D.K. Lobial and Dr. Karan Singh of JNU, New Delhi, and we have seen number of participation from various academic institutions, organizations, industries, and companies. And after having discussions and exchange the ideas on various topics and fields, which is very useful for the further development of the society. First, ICCCS was organized in Dronacharya College of Engineering, Gurgaon in 2016. And second, in the same venue in 2018. We have seen and we are happy number of participation always. And our organizing committee members, all the advisory board members are working very hard to make the program a success. Once again, on behalf of all the members of the organizing committee and advisory board members, once again I welcome our honorable chief guest of honor, delegates, speakers, session chairs, participants, and all the students in third ICCCS 2021 today in the morning. Thank you and wish you all the best.
Thank you, sir, for a warm welcome speech. Next, here I would like to welcome our General Chair, Professor Dr. D.K. Lobial, JNU, to give a welcome speech. Dr. D.K. Lobial, he engaged in teaching and research in the university for last 21 years. He awarded 25 PhD and around 50 MTech students have been awarded degree under his supervision. Areas of research interest includes wireless networks, natural language processing, and computational neuroscience. And he has published more than 100 research articles in the International Journal of reputed, including IEEE, ACM, Elsewhere, Wiley, and Springer. Welcome, sir. Over to you, sir.
Thank you. Just a minute.
Good morning, sir.
Good morning, everybody. Good morning, Professor Prasad.
Good morning.
And Good morning to all the participants and Honorable Chief Guest Professor Kishan Lalji and my
Good morning,
friend
sir.
Professor. Huh? Yes.
Good morning.
Am I audible?
Yeah,
Yeah,
please.
sir. Good morning.
Yeah. Good morning, everybody, and my friend Professor Prasad, Professor Mandoria, Dr. Karan Singh, and others attending this conference, the distinguished guests and the participants. Very warm welcome. As Professor Prasad said, this conference has been organized for last 3 years. This is the third one, and I'm lucky one who has been attending all the conference and participating on some capacity, either a speaker or participant, whatsoever it is. It is my privilege, my honor. But let me put this conference is on communication and computing. There are two notions, two aspects. If you look at, let me talk on what does this communication theme is there. If you begin from 1870s when Hertz started, or Maxwell started with that there is a possibility of a electromagnetic signal, which was realized later on by Hertz, Heinrich Hertz in 1890s around. And look at the whole development of communication and going slowly, and then Gramwell coming and making it possible to have a communication. And the first word he said is hello world. That's what when you write a computer program and the first thing you print of hello world, right? It comes from the Gramwell when he discovered telephone, and the first time what he speak is hello world. That's what the history of communication goes. And if you look at the entire development, then analog communication comes, we have televisions, and then digital communication came in 48 when Shannon gave an entire theory of a digital communication, and then whole era of communication was revolutionized by digital communication, keeping in mind the difficulties faced by the industry and the communication world in terms of the analog signals, because it is highly impacted by noise, and dealing with noise was the most difficult part. And this is what which goes with all communication. And when I'm referring to communication, we are referring to voice communication, where telephone network, large telephone network was established, PSTN, Public Service Telephone Network. And see, the requirement of this voice network is quite different from the data network what you use today as the internet. And the voice network has its limitation that it's a what you call a constant bitrate traffic has to go, because we can't go beyond a certain limit. We speak at a limit, and then you can transmit only that much data. So constant, almost all humans speak in a similar way and at a constant rate. Then if you go, it has a limitation that the delay has to be within the limits. If a delay goes more than that, you will not make out what the speaker is speaking. And when you go beyond and see that the jitter, the difference in the delay at different times should be constant, almost should not be varying much, then you will not be able to get a proper voice, what you get in case of a VoIP, a breaking voice. That's what the constant jitter, or a limit with constraint with the jitter, constraint jitter, that is a limit, and delay on a limit on the delay, and constant bitrate traffic. That has been the nature of a voice communication. Then as digital communication came 60s, we started again with the wireless communication, where we have without the wire link, we are able to communicate. And if you go in 70s, then this whole thing started with your TCP/IP, all your OSI model, that computer network was introduced. And at the same time, the development of cellular network also began. And that's what, again, a second revolution came when a computer network was started. And if you read, and it was told that the communication industry, or the communication is growing faster than the transportation. That was the only network. The communication network was growing with a higher speed. And then the moment we moved to 80s and things were started stabilizing, we have a cellular network in place, first G, and then we have whole TCP/IP coming as a well settled or well established network protocol, and then whole IT, that is computer and communication, that is what we call IT today. So that is another. See, if you look at the history of revolutions from digital communication, if I go 1948, don't go behind that, though it comes from 80s, but digital, then wireless, then whole computer network. That's what the whole journey of your communication goes. Now, today, if you look at, we have never imagined that there is a possibility of IoT and what called network of everything or network of all people. So now the expectation is 7 billion people at a time will be connected with the 7 trillion devices. That's what the whole journey of communication is. If the day we see the whole IoT implemented with the 7 billion people around the world is connected together with more than 7 trillion devices connected together, imagine what kind of world we'll have a day coming. And that too is when we have interactive gaming and virtual reality possible. That's what the whole journey, if you look from a small voice communication of 4,000 bits per second. Now today we are talking of giga and gigabits per second. And the delay, if you look at, even 4 or 5 years back, if you go, the TCP/IP delay for communication from one corner to other corner, especially I am talking of India and US, was 200 milliseconds. And whereas for US, some of the cities, almost zero. That is what they said, but zero, it cannot be possible, but very low. And African countries, it was more than 300 milliseconds. And today, with the 4G communication, the delay has come to around 50 to 30 milliseconds. Look at the progress we have made in the area of communication. And now we'll go beyond that. The virtual reality will only be possible, or interactive gaming will be possible, when this delay comes to almost zero. That may be less than 5 milliseconds. That is what is imagined. That later on I'll talk a lot more on that. But the whole journey, see, I take in 3 terms. Using a small bandwidth or a signal of, excuse me, maybe the voice signal of 8,000 kilohertz. Now today we are talking of 28 gigahertz or 60 gigahertz signals we are able to use today. Now look at from small, even not kilobits or simple some bits to gigahertz, and a delay of seconds to a few milliseconds. And the kind of devices we have today, we got, it has been possible with the kind of switching and kind of routing availability today has totally revolutionized this communication industry. I think that is good enough with the historical perspective of the communication, and therefore the communication and computing has been combined together to call it information technology, and that's why the theme, both communication and computing, has been given the name to this conference. I wish all participants will enjoy throughout this 3-day conference, and thank you for inviting me to give this talk, short, brief discussion on communication. Thank you very much.
Thank you, sir. Thank you, sir, for giving a deep introduction of networks and how it is evolved in the area of communication network. Thank you so much, sir. Next here, I would like to welcome our General Chair, Professor H.L. Mandoria, GB Pant University, to give a welcome speech. Professor H.L. Mandoria, he is working as Head of the Department, Information Technology, College of Technology, GB Pant University of Agricultural Technology, Pantnagar, Uttarakhand. He has received his PhD in Computer Science and Engineering in the year of 2003 from Maulana Azad College of Technology, Bhopal. Professor Mandoria, he has 29 years of teaching experience and research and extension experience, out of which 2 years at international level. His primary research interests are computer networks and information security. He has published many number of books and book chapters and 90 research papers in reputed international, national journals and conferences. So welcome, sir. Over to you, sir.
Thank you, ma'am. Thank you
Thank you, everyone, and good morning to all of you. And on the behalf of all the members of the organizing committee, I'm honored and delighted to warm welcome you all uh, to the inaugural session of the third International Conference on Communication and Computing Systems. As we know, it's a big event for all of us during the Corona 19 period. Before Corona, we would have not think of organizing such an events on in the online mode. Definitely, Corona 19 period has taught us many things, how to manage the things online, and it has become a reality today that everything is being managed online, be it teaching, be research, and many more things. So, as a general chair, I have been given the topic computing to talk about the computing, uh, which is the second term of the this conference. So if you look at the technology, it's constantly updating at such a fast pace that it seems that it is might be the faster than the light, or we can say the technology or a programming language that is making the round this week may be obsolete by the next few days. So learning and enhancing your skills are vital in this technological era. We come to the term, the computing. As you know, this is the process of using computer technology to compute a given goal-oriented task, or we can say any activity that uses computer to manage, process, and communicate information. So, in the other sense, we can say it's more specific based on the context in which it is used. For example, if I say an information system specialist will view computing somewhat differently from a software engineer. Regardless of the context, doing computing well can be complicated and difficult because society needs people to do computing well. We must think of the computing not only as a profession but also as a discipline. So we can say the fundamental question underlying all computing is that what can be efficiently automated. So some of the uh, techniques we use, technology we use like soft computing, cloud computing, Internet of Things, cybersecurity, supercomputing. We can say what will be the computing technology that will power the tomorrow. So in this age of the information overload, technologies can just solve problems through steps, and procedures are no longer adequate. We need technology to detect complex patterns, trends, and to automatically solve these problems. So in the new era, we can say some of the technologies are coming in the frontier of the computing technology. One is the artificial intelligence. That is the technology used for equipping computer systems with the ability to make decisions like humans. Being one of the trending technology, when AI are fed into the system, the aim is to mimic human intelligence for performing complex tasks such as pattern recognition, speech recognition, weather forecast, and medical diagnostics. Another we use the supercomputing. That is the system that operate at a high compute to input output ratio and delivers a very large number of the effective computing cycles per second. So two of these supercomputers from India, Param Siddhi AI and Meher, have made 63rd and 146th in the latest top 500 list of the world's most powerful supercomputers released in the November 2020. So this shows the how the computing technology are important nowadays. And the another term we use, the Internet of Things. That is a network of devices that are connected to each other. Their devices can interact and share data with each other. So these devices may be connected via Wi-Fi, and they share their data about their environment and how they are being used. So many devices we use like this. Another term technology we use, the virtual reality. Virtual reality is the technology by which you can immerse yourself in an environment that seems astonishingly realistic. So it is the use of computing technology for creating a simulated environment And another technology, we use the edge computing. Edge computing, this is the latest technology trend that is getting famous by today. So that is the technology based on the philosophy of bringing computing power as close to the source data source. That this helps in reducing the bandwidth and latency. So technology aim to run fewer processes in the cloud and shifting these processes to the locations such as the user system or an edge server. So bridging this gap between the data and the computing reduces the long distance communication between the server and the client, which in turn enhances the speed of the processes. That is why the edge computing is very used for handling the time sensitive data stored in the remote locations that have limited connectivity to the central locations. So that technology will make cloud computing IoT devices faster. These are the truly exciting time in the computing as we move towards the true intelligence. So these recent advancement in computing technologies are the base for the society of tomorrow. So I'm not going to discuss into detail. In short, I'll say the so we can trust we will be successful in discussing all these technologies in the conference, and many authors will discuss on these topics in the conference, and this conference will be very much interesting for the participants also. So thank you very much for giving me an opportunity and to discuss about the computing. Thank you all. Thank you very much.
Thank you, sir, for giving a deep information and knowledge of computing and its classification, which is applied in our real life. Next, I would like to welcome Dr. Rishabh Anand, Global Service Delivery Manager, HCL Technologies, to give a brief introduction about iCars.
Yeah.
Dr.
Good morning.
Rishabh Anand, sir, let me introduce first.
Sorry. Yeah.
Dr. Rishabh Anand, he is an eminent academician, plays versatile role and responsibilities, juggling between industry research, publications, and consultancy. He has completed his postdoctoral degree with the specialization of AI/ML from Sao Paulo State University, Brazil, and PhD from University of Bristol, United Kingdom. He is also the reviewer of IJTE SSS, IJISP, IJCAC, IJECME, IGICTE, JITR, IJMPA, IJTHI, and etc. He is a prolific author with 34 text and reference books to his credit, out of which 4 books are listed in AICTE Indian Authors List. He is also associated with various professional bodies like IEEE, LMCEGR, IAENG, Internet Society, IAOP, and IAOIP. Welcome, sir. Over to you, sir.
Thank you, everyone. So thanks. I would like to thank Mr. Brij Mohan Kumar Prasad because I did my engineering from Dronacharya College of Engineering only. I would like to thank him for inviting me for the first time in this conference from her busy schedule as I'm occupied most of the time from IT work. So before I give you the overview on iCars, I would like to, give you the brief because from IT perspective, we are already working remotely most of the time, providing 24/7 support. But from education perspective and other organization, banking sector, this was the first time during COVID-19 we are indulged with Microsoft Teams, Skype for Business, and other remote conferences which will be happening and working from home sort of technology which we are currently doing. So let me give you the brief over the iCars. So International Center for Advanced Research and Studies is running under aegis of Srimati Girja Devi Charitable Trust, registered Delhi. iCars works with school and university students, academicians, industry person to promote their scientific temperament towards environment by conducting some environment activities, including tree plantation drives as well as smart computing and security. ICARS mainly focuses on the areas such as science and technology, smart companies, and smart computing, etc., and try to engage with the youth of the society by conducting various workshops national and international conferences, seminars, and synopses, etc. International Center for Advanced Research and Studies has been working towards helping the young and meritorious students who wants to achieve something in their society but are unable to do because of the financial constraints in their families. And it also advocates and has been instrumental in working towards achieving economic and social independence of the self-reliance of the women in Delhi and NCR. So I would like to thanks for giving me this opportunity again, and looking at the curriculum which we have for this particular duration would be very interesting to know about communication and computing systems. Thanks, everyone.
Uh, Thank you, sir, for giving a brief introduction about this ICARS. And next here, I would like to welcome our chief guest, Professor Kishan Lal, co-chair, IAP for Science, the Global Network of Science and Academics. So, Dr. Kishan Lal, he is a co-chair of IAP for Science, the Global Network of Science and Academics. He is immediate past president, the Association of Academics and Societies of Sciences in Asia. His research specialization are solid state physics, materials characterization, crystal growth and lattice imperfections, high resolution X-ray diffraction, instrumentation, quality management, certified reference materials and data for materials. Dr. Kishan Lal, he has edited 9 books and volumes, published 22 invited papers in journals, chapters in books, more than 100 research papers in referred journals, and 7 patents to his credit. So I welcome Dr. Kishan Lal. Over to you, sir.
Thank you. Thank you. Primarily, I start by thanking Dr. Prasad, who was very persuasive as always and
Thank you, sir. Thank you.
insisted that I join you. But I also recall with pleasure my earlier visits to your institute 2, 3 times, and it was a great pleasure to see how you are training young people into different branches of science and technology in particular. Now, in today's context, you mentioned I also served as president of the Indian National Science Academy, and now in the international body, the IAP, which is a association of 109 science academies. It's a organization of 109 national science academies of the world, which come across all these regions. And just to mention that communication has made it possible we to remain active even when the physical movement is limited within a city or within a country. Now we can't meet, though we have had a lot of activities in IEP for meeting at different places, different regions, because for Asia, I was also the president once. But the communication technology enabled us to remain quite active. Of course, it has some peculiar offshoots. For example, we normally, our travel budget in this whole organization, by the way, I must mention that our head office, our secretariat is located in Italy, Trieste, where this International Institute of Theoretical Physics is there. But we get a certain, actually, this organization was founded at the request of Italian government. And they, at that time, they had a very visionary chief of the government. He got, through his parliament, approved an act that they will give every year to us, IEP, a certain amount of money. Now, today, that money makes us also, there is also a pressure on us to do activities and so on. And now we, more or less once in a month, we have a meeting. And now again, there is a doodle. We have a doodle poll so that we know which is the most convenient date for everybody. And we remain active. We can contact, and that is the greatness of communication. Communication has put enormous amount of possibilities. In India, I find with my kids and everybody, they are always doing. I am also now associated with KRM University. They have created a chair in the name of C.V. Raman, and I interact with young students. And twice a week, I use the same method to get this interaction going. Now, this is one thing that what I want to mention, that one major event which has happened recently is in the field of measurements, and which is over encompassing. It concerns all disciplines, whether you are in computing, whether you are in communication. I was a little bit tempted to talk about the quantum computers because government had created a task force. I chaired that, but not. I will, because of the time, I will uh, restrict to two, three things. One is a very recent change in measurement science. In measurement science, all of you start knowing from school days that there are 7 base units: mass, length, time, and so on, electric current, temperature. We are 7: candela, the uh, luminous intensity, and so on. And each of these units had a definition. And to make it interesting, I may say, most of you may be knowing, if you buy a scale in the market, generally the shopkeeper understands futta, or if you are a little bit more sophisticated, foot ruler. What is this futta? Most people may not know that this was nothing but the length of the foot of the ruler of that time. And it changed with the ruler. Then the French were very scientific minded. They connected the unit of length, meter, to diameter of earth to begin with. So karte karte, we moved. Then a treaty was signed more than 100 years ago. And this treaty continuously upgraded units. One of the things is that can we make definition of units independent of artifacts? So one of the biggest challenge one could do with, for example, the length you could first do in terms of a laser light wavelength, and more later it became in terms of velocity of light, which is fixed 299,792,458 meters in a second. 9-digit, every physicist must remember: 299,792,458 meters in a second. But the most obstinate in this was the kilogram. There is an International Bureau of Weights and Measures in Paris, and this would certify the weights and measures of each country which is member of that treaty. India has been very soon after independence. The government realized, and that is why National Physical Laboratory was created. So in this, each country was initially given 1 meter rod and 1 kilogram a platinum iridium weight. If some of you are interested, I can look for, I have a copy with me. But this problem with this was every 4 years, like human beings, it will put on some weight. And all kilograms would go to Paris, had a bath, and they will have a new value and come back. So this all had to be sustained work was done so that we don't connect it with artifacts. So this has happened only, I am saying, because you are a university, only about year and a half ago, even not year and a half ago, little less than that, little over a year ago. Now, all the units are connected with fundamental constants. The most obstinate was kilogram, and now kilogram is connected with Planck's constant. Planck constant is, if you, all of you may be knowing, if you connect energy with frequency h nu, you can, you know all of it. And this constant has been fixed by sustained measurements. It is not just arbitrary, it has been fixed. And now the kilogram does not go. As an anecdote, I may tell you, whenever a new director is appointed in National Physical Laboratory, he used to be given a meter rod, which is platinum iridium, very expensive, and 1 kilogram, which is also platinum iridium, very expensive. And this is the only handover and takeover. And but in their meetings, what I have attended a few times, not less than 6, 7 Nobel laureates are there. If you did something, it will come to that. So now, because you are a university, I must emphasize the present measurement system must be taught in India in every way, that now you have to connect all your all units with fundamental constant. Like I said, velocity of light, Planck constant, uh, Boltzmann constant, all 7 units are now connected. I'm not going to recall all of them. That is my field and so on. But that is one change that has taken recently. The other change which is affecting entire world is this virus which is causing this COVID-19. Now, if you look from the point of view of material science or science in general, one wonders what it is happening. In principle, you see this is a molecule which immediately connects with it covers itself, it's a protein, it covers itself with a layer of uh, fat. And because the overall it is fat, it immediately attaches, whether it is your windpipe or the breathing system, and chokes it. Now the question is, how does this happen? So today, one of the challenge where many people are working on what features of the structure make it possible and how these can be controlled. So IAP, with which I am co-chair, we have several specialized groups which are also coordinating or putting together information in this. We are not a research organization, but we keep in view all that is taking in place. Now, if you see in general, a material's behavior depends upon 4 factors. If you take a material, even if you take a piece of iron and you say, I want to use it in automobile, all of you cannot use it, because it must have, for a particular application, well-defined composition. What are the constituent? What is their percentage? Then what are the impurities? Not merely constitution, impurities. Then comes the structure, that how atoms are organized. It is this structure which distinguishes the graphite, which is coal in carbon, from diamond. वही कोयला डायमंड बन जाता है if you organize the structure properly. One is the softest, other becomes the hardest. लेकिन ये भी काफी नहीं है. If you take a silicon which is used extensively in chips, whether you are preparing chips for computing or communication, but there you have to make sure its structure, it's a cubic double FCC structure, but its structure is the same and there is no imperfection in the structure. That has been my field of research. So even if one sheet of atoms is extra or missing, it changes the properties together. For example, with one sheet of atom, for example, mechanical strength can be changed by 100 times. It depends. That is the type of impact it has, and very few laboratories could see directly. And I was very proud. In our lab, many people came from abroad to work when you want to increase this. But coming back, this is a great challenge. The COVID, this virus, because as many of you, I am also reading, it changes its form. It is not the same virus which it is started. It has changed form. Now in UK, they are saying some more deadly variations are coming in. In India also, there is a fear. But the more we understand, the more we realize how it's structured, different components. And I must mention, in India also, macromolecular crystallography is quite strong. Crystallography itself is quite strong, but macromolecular crystallography, where these detailed structures are possible to put atoms, ions in a particular perspective, and also to negotiate whatever changes you want to do this. So this is an exciting time, and I am sure Dronacharya Institutes, set of institutes with very enthusiastic people like Professor Prasad and others will make it a hub, a center where exciting things will happen, and they will generate new knowledge and impart exciting areas, knowledge about exciting areas to their students and others. So thank you very much. I'm very pleased to be here, and thank Dr. Prasad and other uh, senior professors and chiefs in the Dronacharya set of institute. Thank you very much. Namaskar.
Thank you, sir. Thank you. Namaskar, sir.
Thank you, sir. Thank you, sir, for sharing your experience in the field of computing. Really, we feel very proud to have you here in this conference. Thank you, sir. The conference always goes successful when we put great effort and dedication. So, there is no inaccuracy in the success of this conference efforts made by our team and the only one-man army who is Dr. Karan, sir. Dr. Karan Singh, he received engineering degree from Kamala Nehru Institute of Technology. He received MTech and PhD from MNIT Allahabad. Currently, he is working as an assistant professor in School of Computer and System Sciences, Jawaharlal Nehru University. His primary research interests are in computer network and computer network security. He has published a number of research papers in reputed journals and conferences, and he also organized a number of workshops and conferences. So, please grace this conference by giving vote of thanks. Welcome, sir. Over to you, sir. Karan, sir.
Hello.
Good morning, Dr. Saab.
Is there?
हेलो
Good morning.
सर आपका माइक से इको
Just hello.
now it's okay.
Okay. So thank you very much. On
So still it is resounding.
same issue is there.
Yes, sir. Yes, sir.
बाकी लोग अपने म्यूट कर लें ऑडियो.
Hello.
अब
Hello.
ठीक है, अब
Yes,
ठीक
sir.
है.
Now it's clear.
Yes, yes. Okay. Thank you.
Okay, Dr. Saab. Okay. Good morning.
So first of all, good morning to all of you. And on the behalf of the organizing committee, I thank you to all. First, I thank you to our chief guest, Dr. Krishnal, who come in conference in very short notice. So thank you very much, sir. After that, there is a organizing team, and there are the general chairs, Professor D.K. Lobial, sir, Professor H.L. Mandoria, sir, Professor BMK Prasad sir. So thank you all of you. You believe on organizing committee and provide a good lead to organize this conference. Then I thank you to our guest and speakers like Dr. Ali and Dr. Noor. So they will come and provide the session in this conference. So in advance, we thank you to all our speakers. Then I thank you to our session chair who will take and provide their valuable time for evaluate the conference papers. So I thank you on the behalf of the organizing committee to all session chairs. Then I thank you because without authors, it is not possible that the conference will be organized. So I thank you the all authors who provide their research paper and going to present their work in this conference. I think they will take some benefit of our speakers and guests. Then I thank you to all organizing team who did the wonderful job day night. They provide their effort. So I thank you to all organizing members, team, volunteers. So and at the final, I thank you to those who are going to involve in this conference directly and indirectly. So again, welcome all and thank you all of you.
Thank you.
Thank you.
Doctor.
Thank you, Dr. Karan.
Thank
Over
you,
to
sir. Thank you, sir, for vote of thanks. And here I conclude the inauguration session of our conference. Let's have a break of 10 minutes and then we'll start with further schedule of speech of speakers. After the break, we will meet in the same meeting. Thank you all.
Thank you, sir. Thank you.
Thank you. Thank you, sir.
थैंक यू। कैसे हैं मंदोरिया साहब?
सर मैं अच्छा हूँ, आप कैसे हैं सर?
बस सब बढ़िया है, कोविड में घर ही में है और कैसी सब चल रहा है।
सर वो घर में बैठ के देखिए सर कैसी एक्टिविटीज आप करवा ले रहे हैं।
अब क्या करें, मजबूरी क्या क्या नहीं कराती।
मोहन सर जी को नमस्कार। मैं शायद आपसे पहली बार ही मिल रहा हूँ।
नमस्कार सर, नमस्कार। आपकी बराबर चर्चा होती है सर लोगों के बीच में।
So nice of you, सर। आपको मैं देख रहा था कि आपने 2016 में भी कराया है इसी।
अरे इतनी बार मिल गए हम, आज आपका पूरा नाम पता चला।
डॉक्टर साहब लोग बस इन्हीं लोगों के साथ हम लोग जुड़े हुए।
मैं ये कह रहा हूँ इतने दिन से चलते बीएमके जी का आज पूरा नाम पता लगा हमको।
ये देखिए हमारा रिसर्च हो गया सर। ये
रिसर्च हो गया। करण सिंह को पता था क्या करण पहले से?
नहीं सर, मैं तो बीएमके बोलता था सर को।
हम भी वही कहते हैं, तो आज पूरा नाम पता लग गया। देखिए
अच्छा लगा सर। अच्छा ज्वाइन किया और बहुत सारे लोग हमारे इस प्रोग्राम में पार्टिसिपेट कर रहे हैं, बहुत अच्छा लग रहा है। और बहुत हार्ड वर्क किया है हमारे करण सिंह जी ने।
अरे
करण सिंह तो
साहब ने भी।
करण सिंह जी तो हमेशा से ही ऐसा लगता है जैसे कि
और इनकी पूरी
हार्ड वर्क कैसे कर लेते हैं।
इनकी पूरी टीम लगी हुई है।
अब तो करण सिंह का हार्ड वर्क तो इट गोज अनसेड।
That's true, sir.
नहीं सर, सभी का है इसमें इनपुट।
नहीं यू आर हम्बल।
करण सिंह जी का जो मतलब
जज्बा है ना,
मैनेजमेंट पावर है वो वेरी स्ट्रांग है।
उससे भी स्ट्रांग जज्बा है।
हाँ जज्बा है, डेडिकेशन बहुत ही स्ट्रांग है।
सर आपका कैमरा थोड़ा सा आधा आ रहा है लोबियाल सर।
हाँ मैं बैठा कुछ को झुका हूँ ना।
अब पूरा आया।
अभी अब ऐसी चेयर पे बैठूंगा, अभी तो सोफे में बैठ के कर रहा था।
हाँ हम फोटो वोटो ले रहे हैं तो आधा चेहरा आएगा, फिर पता नहीं चलेगा। इमेज प्रोसेसिंग से निकालना पड़ेगा कौन है।
लेकिन लोबियाल सर आपकी छत छाया में जो है करण बहुत अच्छा कर रहे हैं।
नहीं हमारी कोई ऐसा नहीं है, वो अपना इंडिपेंडेंट है।
नहीं इंडिपेंडेंट नहीं है सर।
लेकिन ये कि साथ अच्छा मतलब क्वाइट प्लीजिंग है कि करण लगा रहता है। ये है आजकल डेडिकेटेड लोग मिलना बड़ा मुश्किल काम है।
Yes, that is true,
हाँ,
sir.
सही बात है सर,
हैं?
बिल्कुल सही बात।
सही बात।
Good morning, Karan sir. Good morning, Lobial sir.
Good morning.
गुड
Good
मॉर्निंग
morning,
लता,
sir.
ठीक है?
Good morning, Prasad sir.
गुड मॉर्निंग।
सर अब मैं लीव कर रही हूँ।
हाँ हाँ हाँ, कोई नहीं।
हाँ,
Bye.
थैंक यू लता। इसके बाद आप ही का है सर, लोबियाल सर।
अच्छा, तो मैं तब तक पानी आने पी लेता हूँ फिर।
हाँ बिल्कुल सर।
फिर 10 मिनट के बाद मिलते हैं।
और क्या, कमर कस ले, पानी पी ले।
हाँ, फिर 10 मिनट के बाद मिलते हैं।
हाँ
हाँ नहीं, टाइम पे खत्म हो गया हमारा इनॉग्रल।
हाँ हाँ, नहीं सही हो गया। हाँ,
नहीं, अच्छा हो गया।
वो शायद वो मलेशिया वाले ज्वाइन नहीं किए, कर पाए।
वो 12 पे एक्चुअली उनकी मीटिंग थी, 12:15 पे आएंगे वो। जब
ओके ओके।
आपका लेक्चर होगा ना
हाँ
खत्म,
हाँ
उस समय आएंगे।
ओके।
वो कह रहे मुझे मीटिंग आ गई, इस वजह नहीं मैं आ पाया।
हम्म।
तो उन्हीं का 15 मिनट बचा है।
हाँ हाँ हाँ, उन्हीं का बचा ये।
चलिए, अब तो आपका सर शुरू हो जाएगा
हाँ
10
बस।
मिनट के बाद।
हाँ
हाँ, कोई बात नहीं है, तब तक सब लोग पानी वानी पी लें।
हाँ हाँ, और क्या, शुरू करते हैं।
ठीक है सर।
ओके सर।
ठीक है जरा।
करण, हेलो। हाँ प्रसाद सर, हेलो।
हाँ सर।
यस सर, प्लीज।
मैं जरा थोड़ा सा कुछ ऑफिशियल काम है तो मुझे लीव करना होगा।
हाँ हाँ ठीक है सर।
हाँ हाँ, कोई बात नहीं सर, फिर बाद में आप
ओके।
ज्वाइन कर लीजिएगा सर।
ठीक है
ठीक है ना
सर,
सर?
थैंक यू।
हाँ, ओके सर, ओके।
Hello.
Yes, sir.
कब शुरू करना है?
Yes, sir. That's why I asked to Karan, sir, but he's not
Okay.
replying.
Okay.
Shall I start?
अच्छा वेट कर लो 2 मिनट करण का, कोई बात नहीं.
Okay, sir.
हाँ सर,
हाँ मैं तो रेडी हूँ, बैठा हूँ.
स्टार्ट करवा दे सर.
हाँ हाँ मैं तो तैयार हूँ.
ओके.
Welcome back. On behalf of ICARS New Delhi, I would like to express my gratitude to the presence of all delegates, speakers, and participants in this online international conference on communication and computing systems. Now we have with us Professor D.K. Lobial sir from School of Computer and System Science, JNU, New Delhi, for the keynote speech on 5G networks. Let me take the privilege to introduce you all with Professor D.K. Lobial sir. Sir is engaged in teaching and research in the university for the last 21 years. Sir has supervised 25 PhD and around 50 MTech students. His area of research interests include wireless networks, natural language processing, and computational neuroscience. Sir has published more than 100 research articles in the international journals of repute, including IEEE, ACM, Elsevier, Wiley, and Springer. I consider it a great honor to welcome Professor D.K. Lobial, sir, and I request you, sir, to proceed over the session. Thank you, sir. Over to you, sir.
Okay, thank you, Monica. Let me share my screen. मेरी screen visible है?
Yes, sir, it's visible.
Okay, I will take it to what to call a presentation mode, na? Slides. Okay. Shall I switch off my video? Huh? Okay, now as in the inaugural session, we talked about it's a conference on communication and computing, and communication being one of the key area of the conference. I thought it would be appropriate to talk on the latest communication network, which is still to come. That is 5G and its application. Probably towards the end, we'll have question answer. Let me see. Okay, so what I'm going to talk in this lecture is, and this talk is, I'll give a little introduction. Now, introduction is important in a sense, how we move from one generation to another generation. And when I'm talking about this, we are not going the bookish way, what we teach in which we study in the class. That's not my aim. My focus will be that when I talk of these, what was the compulsions and the requirement and the issues and the challenges in the generation which were needed to be addressed, and that therefore gave rise to the new generation, and what actually we achieved in the new generation, and then what were also again problems with that. And with this, from 1 to 2 to 3 to 4, then we move to 5, and then we'll move. Every generation has some theme, some goal, and so is the 5G. And then there are limitations of the demand, because the demand in the market growing, whether the networks are able to meet those demands of the consumers and the users or not. Will there be any limit on that demand, or it will infinitely keep on going? That's what. Even if the demand grows, there is a limit on technology, whether we can keep on going, enhancing that limit or not, and how far we have already stretched that limit. And will there finally, whatever we achieve with the development of the technology, will that be suffice, or still we need to go further? Or even if we have achieved more, really we are gaining something out of it or not? That's what the question of limit of technology mean. Then we have certain, in addition to the goal, then we have certain regions as well with our 5G. That is what we'll talk. Then ultimately, any technology which comes, it must have certain applications. If not, then it will be useless. And nobody will, there will be no taker for the technology. And then there is no point. So a technology comes with certain applications of it. What are the applications where 5G will focus? Will be the last. Then I'll try to link 5G with the IoT. That will be 2-3 slides, and then I'll conclude my lecture. That's what the whole track of the talk will be. Let me begin with what is happening. If you look at this graph, you'll see that every 10 years a new technology comes, new generation of wireless network has been coming. It began in 1982, some may call 81, 82, that's what the boundary is, the first generation. Then 1992, the next 2G generation came. Then 2002, third generation. 2012, fourth generation. That's how the generations kept on coming. But 5G was supposed to come in 2020. Had we spent in the pandemic, probably it may come in 2020. But still, there are certain questions which needs to be addressed, whether it will really be coming or not. We don't know, but we'll talk on that. That's what. But it has been a small. There have been a small trials in Seoul Olympic in 2016. Of the 5G trials has taken place. So hopefully 5G will come. That's a whole journey. But how this began? What are the regions that one has to move? If you look at first generation, where the available was, it was analog based system. Number one, we have to keep in mind. And I said analog system always has a problem of noise. So it has a limitation. And the handsets were very bulky because the region was, the battery technology had not grown as the communication technology. We did not have lithium battery at that point of time. And the power you need in a battery was, you need to use more material. The battery size was bulky. Therefore, the handset also become bulky. One. That was one. And other problem with the 1G were that this biggest problem was the security. There was a apps dropping. Anybody can intercept the signal. There was a phone cloning and identity stealing were the big issues with the 5G. We do not have a technology kind of digital technology, so we can't take data and then manipulate and see it. Only the signal was good enough to be stolen, and then you do whatever manipulation you have to do. Fragmentation, that means every country has a different technology. There is no unified technology as far as 1G is concerned. That was another problem. And the cost of delivery of service was very high. Only wealthy people used to have first generation mobile phones. It was very costly. And then also carrying it was a problem because it was bulky. And the quality and capacity of analog transmission was low. The moment I am saying this, the capacity, it does not have a large bandwidth. The signal cannot travel to a longer distance, and the quality of the signal was not also very good. And therefore, to resolve those issues to a fair degree, we need a next kind of cellular network. That gave rise to the emergence of 2G. And the first problem, analog, and the 2G was totally changed into digital communication. That's one advantage. Once you come to digital communication, then it's good that the security can be handled because everything is in the form of data stored in a machine, computer machine, and then you can have encryption, decryption, or other measures of security can be applied. That's what the advantage of this. So the security to a certain extent, because even if somebody steals away the signal as in 1G, because your data, whatever is traveling is encrypted, and he may trap the signal, but will not be able to decipher the signal. That's what the advantage, and that is how the first 2G came. And 2G also improved the voice quality because denoising or handling with the noise was much easier with the digital communication. Because in analog, when you amplify a signal, noise also used to gets amplified, and therefore noise always remains, and filtering was a difficulty. In 2G, the signal advantage that the signal regeneration. When you do that, you convert into 0-1 bit form, and when you amplify, because signals were in the form of 0 and 1s, so it doesn't matter much until the 0 becomes 1, 1 becomes 0. Otherwise, whatever noise is adding or subtracting from the signal, the 1 will remain 1, 0 will remain 0. So there are not much change with noise. So the quality of signal improves. And GSM, Global System for Mobile Communication, introduced by Europe, and that became a de facto standard later on. So the defragmentation issue was taken care of as far as different country was using different technology. So with the GSM, almost except America and Japan, USA and Japan, rest of the world has been using GSM technology, and US used CDMA while 2G came, and Japan used its own standards. But still, in spite of US and Japan using different technology, there's a possibility of interoperability between these different technologies. So the fragmentation was taken care of by this. And roaming was possible because we use one technology, one standard GSM. So the roaming was possible throughout Europe because all countries in the Europe has been using GSM. And along with that, we started a data service. So earlier only we have a voice service. Now we started with a data service called SMS. That's why sometimes the 2G with SMS called 2.5G. So the data service started with the 2G, and the handsets were also improved in smaller in size than the 1G. So 2G became a very highly successful technology. It was a big change from a very what you call bulky sets, small sets. Quality of the signal improved, the noise was reduced. So if you look at the whole lot of changes in the technology, so that therefore the 2G has been a very successful technology. Keep that in mind. Then yes, 2G was not without any problem. It has its own problems, like the low data rate. The data rate was not very high. So therefore, the difficulty was the kind of services internet provides were not possible with 2G. That's one, because of the low data rate. Like multimedia services, adding pictures and text and video was not, with the text was not possible. there is a limited spectrum efficiency. At the moment I say spectrum efficiency, that means how many bits you are able to transmit per megahertz or per gigahertz or per hertz, whatever you take. अगर आपकी bandwidth 10 hertz की है, उसमें कितना bits आप transmit कर सकते हैं, and per hertz. So the spectrum efficiency was not very high because of certain issues. Therefore, the throughput also was not very high, and the cell range was very small with 2G because number one, therefore the handoffs were more, and handoff period was very high, but still it was manageable. So these gave rise to the 3G, which slowly addressed the concern or the issues that exist in 2G. Now, if you look at 3G, when it started, it entirely aimed at using CDMA technology for the spectral efficiency. That means more and more users can be accommodated and more data can be transmitted per hertz. So if you use CDMA, so more and more users can transmit data per hertz. So that was the basic idea of CDMA, because otherwise the users are restricted by the spectrum you have available. So if you can support more users, that's what the CDMA. But and also at the same time, it provides higher data rate, 384 kbps, if you remember, as far as data is concerned, which can support a picture to a certain extent a video. That is why the multimedia transmission was possible at 3G. And it used circuit and packet switching both, circuit switching for voice, and it also included packet switching for data. One important part came here is that the font size also became a problem in a sense, because you have a very small screen, and if you want to transmit a picture and a video to a limited extent, watching that on the screen size was a problem. So that was also hampering the growth of 3G, because the kind of services you want on 3G was limited and restricted by the kind of a font size and the screen size you are using. And then immediately the development of iPhone took place, and that transformed the entire 3 generation 3G, because the screen size, the quality of video iPhone used to handle was enormous. And then 3G started picking up because of this large screen size of iPhone. But that was still a costly affair. Not a common man can afford that. Only still a kind of wealthy people were able to deal with that. That's what said. But it causes a little rapid growth of 3G. But keep one thing in mind: 3G did not become a highly successful technology. The reason being is, with the all goal of the CDMA, there was difficulties of implementing this CDMA. That's what the problem with the 3G. So 3G was a slow evolution that because it was difficult to implement CDMA. Effective implementation of a CDMA was really, really difficult. If you remember, Reliance started with the telephone service and a mobile service called Reliance Sets. They were based on CDMA. And now we don't know where Reliance gone now, because the reason is the CDMA could not take place. That's what properly. It has its own difficulty, but they improved CDMA with the GSM with a little bit of high-speed packet access that improved the data rate up to 300 something, 84 I said. That even if you increase the data rate, the latency was still unacceptably long. The delay, end-to-end delay on the network was very high. So if you are watching a video coming and not online streaming was not possible. If it was possible, then very slow, not acceptable to a user. That's what the problem with the 3G. So the latency or end-to-end delay was still not improved by 3G. And I said the small screen size, even those who cannot afford iPhone, for the rest, the screen size was small. So browsing internet services was difficulty. Therefore, adoption to the internet became very slow, and therefore 3G has could not play that way. There was a difficulty with a mix of circuit and packet switching. that reduced the network efficiency and difficult to manage. When to go for packet switching, when to go for circuit switching. If you are sending a packet, then a voice call comes and the voice call takes priority over a data packet. Therefore, you immediately move to circuit switching and your data packet was put on hold. And that immediately quickly you're transferring a lot of data, but a lot of calls coming. So switching between packet and circuit was a difficult one, and that reduced the efficiency of the network. So the 3G has a difficulty, and that I said of the circuit switching and packet switching, both mix of that put a difficulty. Small screen sizes and phone development on the phone also restricted. End-to-end delay was a big problem, and difficulty of CDMA implementation. 4 issues came with the 3G, despite a high speed, what you call high speed packet access. This HSPA that I have not HPSA, that is HSPA. 3D could not meet the user's performance demand. What kind of demand the user had? I should be able to watch movie on my mobile phone without any interruption and without slowing down, waiting for the next scene to come. That was what the user's requirement, and 3G could not achieve it, could not meet it. That's one. And that gave rise to the evolution of 4G. Let me put it on top. Then moving from 4G to 5G, if you look at this, one of the advantage with the 4G. Hello? आवाज नहीं आ रही?
आ रही है सर.
अच्छा ठीक है मैंने.
Yes, sir.
ठीक है. Then one of the advantage with the 4G was it used orthogonal frequency division multiplexing, OFDM. So there's overlapping of what you call certain channels, and they're further divided. The channels were divided into sub-channels, and therefore you achieved higher data rate and with lesser interference. And also one of the biggest advantages with 4G was it was made fully packet switching. Circuit switching was removed. It was IP-based or packet-based switching. So even your voice calls were going through the packet switch. Now, as I said, those who have been attending morning, voice cannot tolerate delays. If there is a delay, then there is a problem. वो कहता है कि अपने हिंदी में बताता हूँ कि फोन किया अपने भाई को फोन किया कि भाई मैं आज अजमेर गया हूँ, पिताजी अजमेर गए हैं, मैंने रुई ले ली, आप रुई ले लेना. Say this or the communication because of the delay and jitter in the circuit switching. उसके भाई को लगा पिताजी आज मर गए हैं and मैं रो लिया हूँ, तुम रो लेना. So the kind of what I'm saying, the distortion which goes, if your jitter and delay are not restrained by the constant rate, it goes beyond a certain point, then the whole communication breaks and the meaning gets changed at times because the packets which goes of certain interval, you are not able to make sense out of it. It becomes a different sense. But 4G maintain the delay and latency is that 4G has a very high speed data rate as well as it has improvement in the switches and routers. That's what I'm saying. And the voice carrier carries by the packet switch called voice over long term evolution. जब आप खोलते होंगे मोबाइल ऊपर VoLTE लिखा रहता है. That means your voice in 4G is being carried by the packet switching, not by the circuit switching. And imagine in the packet switching when you have a shared medium, how fast the traffic may be traveling so that you are able to get a proper quality voice. Used wider frequency channels, thus improved latency. So what it does, it uses high bandwidth, more and more users are accommodated, therefore the delay will not occur. 4G has been a stable and optimized network. It tried to optimize all aspects of the network, and it has been a very stable technology. 2G was stable, 4G also was stable technology. And 1G was not a stable, and 3G was not a stable network. 3G kept on evolving. Then we say 3G PPP project plan, and then that gave rise to VoLT or what you call LT, long-term evolution. That's what 3G could not remain in the market for a long time, and so is the 1G. So some people, those who are superstitious, they said 1G odd generations are not stable and even generations are stable. Therefore, we don't know whether 5G will be stable or not. So that is how it comes. But if you go beyond the superstition and be scientific, that is not true. It may happen with 1G and 3G, but not necessarily that it will happen with 5G. The spectrum efficiency, that how many users per megahertz or per gigahertz used, that increased in 4G by 2.5 times from 3G. If it was 10, then it became 25 in 4G. So therefore 4G also became highly successful technology. Though we don't have in India 4G implemented at that large scale, the rest of the world 4G is being used in the developing country, not even in developing or underdeveloped countries. That's what 4G is. Now with this notion, where 5G will be really important or really needed or not. That's what we are moving from 4G to 5G. But what are the difficulties with the 4G? That's what important. Then we'll move to the 5G. Then that is what the topic is. If you look at the limitations of 4G, the data rate is not largely sufficient, but it is sufficient, but not largely sufficient. Keep that in mind. The meaning hereby, it may be sufficient enough to handle the existing or the required applications right now, but still there are few applications which still need larger data rate where 4G will not be able to meet the region, number one, because the 4G still uses a frequency below 6 gigahertz. So you have a spectrum efficiency still low, but better than others, but not. So therefore the question comes, if you have a frequency band less than 6 gigahertz, then it will not be possible to connect a large number of devices together. And if you cannot do that, therefore your data rate is not sufficient one way. Right? If I need to connect in my proximity, like 1,000 devices, can I connect 1,000 devices with my Wi-Fi currently existing or with the 4G? I may not be. And therefore the total data rate is also restricted. And still the latency required, still we need to lower it. That means what I am trying to say is the latency was improved quite well in 4G, but still not to the extent that it is needed to have a interactive gaming and virtual reality. If you have to run the application like virtual reality and interactive gaming, then 4G still has a limitation. It may not work fine. So to improve those issues of requirement of a lower latency and frequency spectrum to be used, which can handle a huge number of devices together. That's what IoT will talk a little later. Then you need a different kind of a band or a spectrum to be used. That will be sufficient to deal with the kind of applications we are talking. So to address the 5G, now this is what the game changer comes. So what I said, 5G has to address the latency, it has to lower it down, and must also give a potential or chances for using a huge number of devices together at a given place at a given time simultaneously. So based on that, 5G has multiple themes. When you talk of 5G themes, it has 3 themes. And generally, when we have moved from 1 generation to 4 generations, every generation has only one theme, whether you take 1G, 2G, or 3G, 4G. The most of the generations have a theme is that we need to increase the data rate. You need a higher data rate so that you can deal with high quality videos transmitted and watch movies. That was the only theme with 2G, with 3G, with 4G. Right? But 5G has 3 themes together. It is a multiple theme based generation. First theme was that it needed an enhanced mobile broadband, which will provide a faster connectivity than 4G. That's what it is, right? One, and also it will right. This is one. Second was massive machine connectivity. If you need enhanced mobile broadband, that means you can use a higher spectrum. One, and second is that it must provide connectivity to the multiple devices. That is massive machine connectivity, and that will be giving rise to Internet of Things, or what I could not giving rise, but probably this theme of 5G was laid around the Internet of Things. That's what the connection between IoT and 5G is. And third requirement was ultra low latency. That means you need your latency, end-to-end latency means end-to-end delay, to be very, very low, so that the applications like virtual reality can be run. So radio solution for applications such as virtual reality, interactive gaming. So three themes: lowering down the latency, providing a large number of devices to be connected, and also providing a broadband, enhanced mobile broadband, that is higher spectrum to be used. Three themes together. Not only that you need a broadband to give a higher data rate, as in other generations it has to be. So how it was achieved, if you look at 5G technology, is one that 5G started with a beam forming, which is called MIMO. Even 4G started with that, and not only 5G. Then I will have multiple antenna communicating at the same time. Rather than one antenna communication in all directions, I will have multiple antenna. Each antenna may be communicating to a given region by some angle. So one antenna is catering to the user only in one given region, the other antenna is other region. So that means there is a space division between the antennas, and therefore you can accommodate more users. And that is what you call multiple input, multiple output. And it was common in 4G, but only 5G, the scale of MIMO was increased. That means while 4G was using only 8 antenna in a mobile, and then 4G will say, yes, I will have 120 antenna in 5G. That means your tower, the mobile tower has 120 antenna at a given point of time at one tower, whereas the 4G has only 8 antenna. 3G only one antenna, it is omnidirectional, transmitting in all directions. That's what one of the technological changes which come with the 5G. And also not only in the kind of antenna or the last mile communication, which is communication from your mobile tower to your mobile phone. That's what we call last mile communication. But also there was change in technology of 5G in the core network. Core network means ultimately the core network consists of your switches and routers. That's what it is. Or your towers are connected and they're connected through switching capability. There are switches and routers. So there is a change in the 5G as well. It said the core network will also use a virtualization like a cloud. And therefore, there are software solutions for switching rather than only hardware solutions. And the kind of virtualization you make on cloud, you can have a virtual switching on your. So therefore, there's a change in the core network. There's a change in the last mile network. That is how. So there's enhanced flexibility in the core network. So how is this achieved? Whether you talk of the technology, talk of the themes. Now 5G talk about 3 bands. Number one, it said we'll use a low frequency band that will be 700 megahertz. And it will also use a mid band at 3.5 gigahertz. And it use a high band with 28 gigahertz. If you look at the previous generations, 3G uses 2.5 gigahertz or 800 megahertz started, and some say 2.5 gigahertz. And even 1.8 gigahertz came late. But what I'm trying to say is the frequency band has not been changing, whether you come from 2G to 3G to 4G. The reason was that to keep the backward upward compatibility, that the next generation still works with the previous infrastructure. The frequency spectrum has been kept same, but only there have been a change in the devices, change in the what you call in the last mile connectivity, but not making much changes in your tower systems. That was with the previous generation, but 5G has a total different. It's at 700 megahertz to be used for a wide coverage bands. Because lower the frequency, the signal attenuates slower, so it will travel to a more distance. So if you go to a village area, probably where there are no much vegetation, not many obstacles, the communication range is almost obstacle free. Then and the population density is not very high, the villages are not densely populated, then a signal of 700 megahertz can work because the number of users are not very large. So therefore, with a small bandwidth, you can cater to more the users and also communicate to a longer distance. That's what. So you don't need to put many towers there. On small number of towers may work. So it gives a wide coverage. That's what. Second is a 3.5 gigahertz, which is a mid-range key band of 5G. That is what it provides enhanced mobile broadband. 3.5 gigahertz was designed to give you enhanced mobile band. That means for mobile services, all communication rather than 2.5 gigahertz, it will be taking place on 3.5 gigahertz. So you have more spectrum, and probably it will reduce the cell size, but still it will be workable. In a dense area like Nehru Place or some places where you need to have communication, probably 3.5 gigahertz may be useful. It is a short range, not like 300 megahertz. Probably it can work. And it also gives you very high band at 28 gigahertz. So in a that means it will be very short range because signal attenuates very fast with the higher frequency. So signal will attenuate, it will not travel to a longer distance. It will be a very small, like in your locality, like your building, your home. Network can be connected with the 28 gigahertz. So you have a modem at home. All connection to modem will go with the 28 gigahertz. So you can have thousands of hundreds of devices connected with your modem at home with 28 gigahertz frequency band. Now or high or band. Now the moment if you say that the latency will lower down, that means and you can have a large number of devices connected, but at the same time, because you give enough bandwidth, so the latency will also be reduced. That is where the massive connectivity, massive machine connectivity will be possible. So three kind of bands were given for three different purposes. So it will be used for a fixed wireless access. That means from your home within, from your devices to your access point. And in your local community, अगर आज की तारीख में देखें पड़ोसी के घर में भी वाईफाई लग गया और आपके यहाँ 10-12 वाईफाई लग गए हैं, तो then you find difficulty of signal in your home because Wi-Fi has a limited channel and each channel can only support a limited number of users for in a shared mode. If one channel is busy and it automatically switches over to next channel, there are 14 channels, only 11 are used generally in US. And then if you are working on channel 6 and पड़ोस में भी वाईफाई लग गया वो channel 7 में communicate कर लेगा. But if you have 11 users, you can have in different channels. If you have more than 11 users, you will share the channels. When you are sharing the channels, increase the number of users, then you will have a problem. So there is a limitation, and but if 28 gigahertz band, then you cannot have that limitation. That's what. But the difficulty with 5G will be that it needs a total change in the infrastructure. Right. So what is the limits of demand? The moment I say limits of demand, one of the important point here is that just 1 minute. Is that the demand is measured in terms of the data volume, the capacity, how much data volume the network is carrying. That's what the demand can be. But the new generation, the speed is more important. That is the May I request, please, if you keep it not play much with this Zoom, then it is coming over my slides, right? इसको नीचे ही रखिए।